Okay, so today we start the basic concept of an array. So, first of all, what do you mean by an array? So, today, now the thing is that an array that is a linear data structure. That means you can say that an array that okay. So, an array that is a linear data structure which stores homogeneous data element in contiguous memory locations. Then what does it mean? That means you can say, what does it mean linear? Linear means actually that means that the data element are stored linearly. And you know what do you mean by data structure? Data structure is nothing but a subject where we discuss about the storage and you can say access strategy, storage and access strategies of data, and which stores homogeneous, that means homogeneous, you can say homogeneous data element, that means the same type of element, same type of element. That means if this is a integer data, then you are using integer. If this is a float, that means you cannot store integer and float in a single thing. That means, so that's why you can say that this is the same type of element, that is called the homogeneous data element. And in contiguous memory location, contiguous means you can say, that means if an element is stored in, you can say 100 locations, the next element should be stored in the next locations, the next element should be stored in the next to next locations. That means they are not stored in a arbitrary manner, they should store in a contiguous manner. But before going to an array, you should know about something important concept, that is called a pointer, because actually array is nothing but use the concept of pointer. So what is pointer? You can say a pointer, a pointer that is a variable. A pointer is a variable which actually you can say stores, which actually stores the address of, you can say, another variable, which stores the address of another variable. So that means a pointer, that is a variable which stores the address of another variable. So now you can say the question, now say, okay, we understood about the, you can say, what do you mean by pointer, right? So well and good. So let's see some of the problems, right? That means one of the concept of pointer is that, say I am just writing some, you know, code, say void, you can say main integer I, integer you can say star ptr, say integer, this one is a star star pptr, integer say star 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 PPPTR, and now I am declaring I equals to 25. Now when I am declaring this star that means nothing but PTR is acting like a pointer. When I am writing double star, then we will see if we want to get the actual value, that means you have to dereferencing it 2 times. That is the meaning of that. So the thing is that in that particular case, what I am written that what is the corresponding picture. If we want to draw the picture, actually what is this I? That means you just see in the left side, this I means a variable and it has some address. Variables means it should store some, you know, locations, right? Since it should store some location, that means it has some address. So if it has some address, that means say the base address, that is nothing but 100, right? This is the corresponding base address, which is nothing but 100. So if this is, you can say 100, say the next is PTR. So PTR is itself is a pointer. Pointer is nothing but a variable. So it has also some address, say 200. Now this is a PPTR, that means this is also another pointer, but it has some address 300, and say PPPTR, so it also some address say 400. And what I am written I equals to 25, that means the value of I is 25. Now what you have to write, that PTR is nothing but ampersand I. What does it mean? That means PTR will contain the address of I. What is the address of I? 100. PTR will contain 100. That means actually they will pointing like that, right? Now what I can write, that PPTR, that is nothing but ampersand PTR. So what is this? That means this PPTR actually store the address of this. That means it will store the address of this. And then you can say that PPPTR, that is nothing but store the address of PPTR. So PPTR, that will store the address of double PTTR. So now it looks like that. That means if you write like that, that means why we are written double star? That means if we want to get the actual value, that means you know PPTR, that will contain an address. This address itself contain another address, and from this address I can get this value. That means you have to dereferencing 2 times if you want to get the actual value, and that's why there is a double star. If there is a triple star, that means if you want to get the actual value, that means you have to dereferencing it 3 times, right? So that is the main thing, and that is called pointer to pointer. That means what does it mean? I am written star PTR. That means this is called single pointer. That means you can say this is, you can say called single pointer. This is called, you can say single pointer. And what we use this for, what purpose? To store address of an integer, and it can dereference up to one value. What is this? Double star, that means this is, you can say called, this is called double pointer. This is called, you can say double pointer. And we had to store address of a variable which is already a pointer. So that's why it can dereference up to 2 levels. And if we say triple star, that means this, you can say, is called, you can say triple pointer. This is called triple pointer, and that means we need to store address of a variable which is already, that means it can dereference up to 3 level. That means if you want to get the actual value, you have to dereferencing it 3 times, right? So that is the main thing, that is the main thing. Now say this is called pointer to the pointer. That means if we want to print 25, that means if we just write say printf say percent %d I, that will give you the value that is 25, right. But if you want to print the same value but by using pointer, you can write star ptr. This star ptr will also give you 25. That means you should know what do we mean by star ptr. Actually, if we write star ptr, that is nothing but value at ptr, and then you have to write like that, value at ptr. You just see that ptr will contain 100. That means value at, you can say, 100. And what is the value at 100? Value at 100, that is nothing but 25. So value at 100, that is nothing but, you can say, 25. So that means if we want to print the actual value, that means you can say that will give like that. That means by using some pointer. So if we write say start pptr, that will give you value at pptr, and value at pptr that will contain 200. pptr that contain 200, that means you can say value at 200, and that is 100. That means this is 100 is nothing but address, right. Now if we want to print the actual value, that means you have to write star pptr. If we write double star, that means that will give you 25. So that means you have to dereferencing two times. You have to dereferencing two times to get the actual value. Now, so that means what we understood from that, we understood that by using pointer, we can get that type of thing. So before going to an array, it is always been better that you should learn something about the pointer. Something about the pointer. So you can say, we can write like that, that pointer to array. That means array is actually behaving like a pointer. Array is actually behaving like a pointer. What does it mean? That means we can say we have to write an array like that. If we write integer say a 5, that means your array will containing 5 elements, say 10, 20, 30, 40 and 50, and say integer take 4 bytes. Say in our computer or in our architecture, the integer will take say 4 byte. Then what will happen? If this is an array A, the element is 10, say 20, this one is a 30, this is a 40, this one is a 50. The index of an array in C, that will start it from 0, 1, 2, 3, 4, and the address, this is 100, next one is 104, this is 108, 112 and 116. That should be like that. So now if we want to access, say I want to access the element A2. I want to access means I want to print the content of A2 locations. Now what will happen if we want to print this content of A2 locations? That will give you, you just see, that will give you 30. But how it can be evaluated internally, that is the main important thing. Actually internally, if we write A2, that would be evaluated like that, star A plus 2 multiplied by the data type. That means what is A? A is nothing but the base address. This A is nothing but, you can say, base address of an array. In that particular case, I took it as 100, but it may be anything, but that doesn't matter. And the size of the data type, this is nothing but the size of data type. Size of the data type, that means in that case I am taking integer as a 4 byte. So that would be 108, and you can say that means value at 108, value at 108 is 30. You just say value at 108 is nothing but 30. So that is the thing. That is the thing means actually internally you can say the array should be evaluated by using a pointer. By using a pointer, it would be evaluated like that. So the thing is that if we want to access AI, that can be written as a plus I, of course multiplied by the data type, and plus is a commutative, that means you can write I plus a or you can write IA. That means whether you want to print AI or you want to print IA, that both will give you the same result. That both will give you the same result. That you should remember. That means this both will give you the same result, AI or IA. So now the next thing is that means this is nothing but pointer to an array, right? Pointer to an array. What does it mean? That means we can say it as a pointer to array. What does it mean? That means array name without subscript. Array name without, you can say, subscript, that actually contains the base address base address of the array. That means if I am just write a, if I am just writing a, that means actually that will give you the whole array, right? So that means array name without subscript, that will contain the base address of an array. So, and this base address, that will be constant and it cannot be modified. It cannot be modified. You cannot change the base address. Like in a class, there is a class monitor, right? If some professor wants to communicate any informations, they will communicate through the, the class representative, right? They did not need not remember all the addresses or all the details of all the students. He just want to know the information about the seer. If he wants to compute any address of any student, he just go through the seer. That means, but if he lost the contact of seer, then it would not be possible for the professor to contact with all other students. So that means this is called the constant pointer. That means you cannot change this base address. Base address is like your class monitor. That means base address this base address, that will be, you can say, constant. That will be constant, and you can say it cannot be modified. It cannot be, you can say, modified. So array name is called as a constant pointer. So you can say array name, that is called as a constant pointer. So array name is called as a constant pointer. So the thing is that, let's say an example, then I think you can understood the particular concept. Say what I am saying. Say I have to write a program, simple program. You just try to understood that particular thing. Say integer a5. This is an array. This array will contain the elements say 10, 20, this is a 30, 40 and 50. Now I am written integer star p equals to a. You just see p is a pointer, that's why I am written star. And what is a? A is nothing but, you can say, a is nothing but the base address, right? So a is nothing but, you can say, the base address. So in that particular case, what will happen? what will happen, that in that particular case what we can do, that if this is an array, say this one is an array, the name of an array is A, say the element is 10, 20, this one is a 30, and this one is a 40, and this one is a 50, and the index is 0, 1, 2, this is 3, this is 4. So this is an array, and of course the base address I can take like that. If this is 100, this one is 104, this one is 108, because I take that integer will take 4 byte. In many books it may be given that will be taken as a 2 byte, but what you can say that that is dependent on the size. That means this is dependent on the architecture. So the thing is that p, that is a pointer, right? This pointer itself is some address, say 200, and it will store the base address of an array, that means 100. So it will pointing like that. This will be pointing like that. Now what we can do? I can do like that, say plus plus p. That means I am incrementing the p. So when I am incrementing the p, that is the difference between incrementing the value and incrementing the pointer. When you incrementing the pointer, that means it will shift to the next data. That means since the integer that will take 4 bytes, that means in the next time that will be pointing this. That means in the next location that will be pointing this. And thus a plus plus p, that means it will shift the corresponding data type. In that particular case, since I am taking the data type is an integer, and integer will take 4 byte, and that's why I am shifting like that. Okay, that's why I am shifting like that. Now what will happen, again I can do say plus plus p. Then if I am doing plus plus p, again that would be shifted and this become 108. That means now that will be pointing to this. Now that will be finally pointing to at the location 108. Now what I just want to do, that is a star minus minus star p. In that case the star will be operated first. Star means value at p. Now p is pointing to 108 and a value at p, that means that will 30. Now you are subtracting, that means minus minus, and that means that will be changing to 29. That means the value of this particular location that will change and it becomes 29. So now if this one is a printf, this one is a %d, and star p, that means star p, that means value at p, star p, that means value at p, that means what we observe. You should make a note, because that is one of the important thing that you need to understood. The first thing that you should understood, you can take as a note. So the first thing is that in the above example, what we understood, that means in the above example, this p and this a both are pointer, that both are, you can say, pointer to array, both are pointer to array, but this p is a pointer variable, because you can change the value of p. P is a pointer variable where a is a pointer constant. This is a pointer, you can say, constant. That is the difference. That means p is a pointer variable where a is a pointer constant. That is the main difference. If you say about the difference, that is the main difference. So what we can say, plus plus p, that allowed. And in that case, what we understood, this is the first point that you have to make a note. The second point, you can say that unary operator, that means unary operator, that associativity is from right to left, So when the pointer variable is incremented, then it will increment with respect to the size of the variable which is point to. That means in that case, since I am incrementing plus p, that means I am just incrementing. What we increment? We are incrementing the corresponding data type. That means when the pointer variable that is incremented, when a pointer variable that is incremented, then it will increment with respect to size of variable which it is, you can say, point to. That means it will increment depending on the size. That means if it is an integer, you are shifting 4 byte. If it will be a character, you have to shift 1 byte, because character will take 1 byte. So depending on the size of the data, you are incrementing the pointer. And in that case, what we observe, the next thing, that means the array name. That particular array name that is given as a constant pointer, you can say, constant pointer, because you can say there is a only source, there is only source in the memory, that is the base address in the memory. How the array contents can be accessed, and since we are accessing the content of the array randomly, because I am using the concept of pointer, that means I can access any element randomly, and we already seen that that will give you the same thing. That means what I am saying, that if I am saying that I am taking an array, that means say array, you don't have to write anything if we have to give the corresponding value. So say 40, 50, and I am just printing the thing, that means %d, 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 %d. If this is a A2, it is a 2a star a plus 2 star 2 plus a, like that. So what does it mean? That means if this is, you can say 10, 20, 30, 40 and 50, and say 0, 1, 2, 3, 4. If this is 100, this is 104, this is 108, 100, you can say 12, 116. So A2, same as that, what I am saying, that they will give you the same thing. That means A2, that means that location, 2A, that will also print 30, because that both are same. Star A plus 2, that will also print 30, star 2 plus A. That means in that case, everything is pointed, printing the same thing. So now one of the important concept, that is called nothing but the pointer arithmetic. That is called nothing but, you can say, that pointer arithmetic. That is one of the important thing. So that means, say I am taking the simple example. Say integer a, on the content of the array, say 10, 20, this is a 30, 40 and 50. Say I am declaring a pointer, that is p1, that is a, that is integer star p2, that is a plus 4, like that. So what will happen? That means if this is an array, if this is an array A, say the content is 10, 20, this is a 30, 40 and 50, 1, 2, 3, 4, and say the address is 100, 104, 108, 112, 116. So P1 is a pointer that will point to 100, that means that will pointing to this location, and P2 is another pointer where a plus 4 actually it would be evaluated like that, a is 100 and 4 multiplied by the corresponding data type, that means 116, that means that will be pointing to 116. So that means what we can say, we can add integer constant to a pointer. You can add integer constant because this 4 is nothing but a constant. So what we can understood from that in the pointer concept, that means we can add integer constant. That means plus 5, plus 3, whatever be the thing, we can add integer constant to a, you can say, pointer. Like that, if you say p1 plus 3, that means actually p1 plus 3 multiplied by the data type. In that particular case I am taking as a 4 byte, so p1 is 100 and this is a 12, that means that will be 112. We can subtract integer constant to pointer. That means you can say, the second note, you can make a note that we can subtract integer constant, you can say, to pointer. That means if we write p2 minus 3, that means p2 that will be 116, that is 3 multiplied by 4, that means 116 minus 12, that will give you 104, like that. We can subtract two pointers. That means you just remember, here I am subtracting a constant. In the first case we are adding a constant, but in that case what I am saying, that we can subtract two pointers. And you can say this is allowed only when both are pointing to same array. And this operation gives number of elements, you can say, number of elements. Like that, if we say p2 minus p1, p2 is pointing to 116, that is 100, so you have to divide it with the data thing, that will give you 4. Now if you see the diagram, this is a p2 and this is a p1 and the number of element within this, that is 4, right? So that is the thing. That means you can subtract two pointer. The p1 is a pointer and p2 is also pointer, and you can subtract it only when the both are pointing to the same array. If both are not pointing to the same array, you cannot subtract. So you can say that would be only allowed operation, but the thing you should also remember something, that means we cannot add floating. You cannot add floating point number. You cannot add floating point number to a, you can say, pointer. Why? Because it has no meaning. Like if we write p1 plus 2.5, that will give you an error. And of course you should remember one thing, that we cannot perform addition multiplication. That means we cannot perform, you can say, addition addition multiplication multiplication, and you can say division between between you can say two pointers, because it has also no meaning, because you can say it has no meaning, because it has also no meaning. That means we cannot perform addition, subtractions and all those stuffs. So you just remember one thing, that is one of the important thing about an array, that you should make a note, because the main thing in an array, that is the base address. So you should make a note that in the C language, if we want to pass an entire array to a to a function, then it is not a good idea. It is not a good idea to pass all the array element, to pass all the array elements. Instead, what you should do? By simply passing the base address, passing the base address of array. By passing base address of array, we can access the array content. We can access the array content. So you can say that are the basic thing about an array. Now you can write, when we will cover functions, then we will see that how you can actually, how you can implement that particular thing. Now the thing is that, okay, we understood about the array, but what we should do about an array, with the array, like that, if an elements are given, say the elements are given like that, say 5, 2, 10, 50, 7, it may be anything, right? Now this array is given. Now if we want to search, say 50, that whether this is present in the array or not, whether this is, you can say, present in the array or not. That is my question, simple question. That means an array is given, it can contain any element. Now you just want to search, say 50, whether this particular thing is present in the array or not. That means that type of problem, that is called the searching problem. That type of problem, that is called, you know, searching problem. And this particular search, that is known as linear search. That particular thing, that is called linear search, right? So the thing is that, okay, we understood. Now if you want to implement that, that means the first thing what you have to do, you have to take the input from the users, right? Then the element should be stored in an array, one dimensional array. Now you have to also take a pertinent item from the users, and the thing is that whether this element or the item that should be present in the array or not, that is our, concern. So what we can say, if we want to write the program, I am just writing this with the explanation. That means say this is a hash include and say this is a stdio and integer main. And what you have to do? You have to declare an array. Say the size of the array is 20. You have to take a variable. You have to take the number of inputs, and you have to take, you want to search something. So I am just take another variable which is item. Now what will happen? You have to give the user enter number of element, because you have to know about the number of elements. And when the number of elements are given, that should be, you can using scanf, you have to store in n. N will contain the number of elements. Now you just give the user that enter elements, and this element should be stored in an array. So you have to use a for loop, and the index will be started from 0, I less than n and I plus plus, and you have to write the scanf like that, %d ampersand ai. So what will happen if this is an array? Automatically the element would be stored, say 0, 1, 2, 3, 4, that means 5 element, and say the user will give 50, 60, minus 3, 2, 1 like that. So that would be stored like that. Now what will happen? You have to take also another input from the user, that give element, you can say you want to search, you want to search. And the thing is, by using scanf, you just store it in item. That means item, say I want to search for the element 2. So item will store 2. Now what will happen? You have to check this 2 with the first element whether it matches. Then you increment, again check with 60. Again you increment, check with minus 3. That will be when there is a match, you have to find that particular position of that particular element. If the element does not found, then what will happen? It will say that the element is not present in the array. And what is the utility of searching? Whether you are searching a book, you are searching a movie, you are searching in Facebook, you are searching in Gmail, at least you do only the searching operations. I am here, we take the example with respect to the numbers, but actually in practical life, in every aspect, you actually do searching. So that's why this is one of the predominant operations in computer science. So you can say, now you want to search for an element, that means I am just using for I equals to 0, I less than n, I plus plus, and I have to check whether this element that will be matches with item or not. If that will matches with the item, if that will matches with the item, that means I can say I can take a break from that. That means that will be out from this particular loop, and you can say and say I can take any other variable, say k variable, I just make it 1, right. So that means initially say k is a variable which is taken as a 0, and now if that will be matches, I just make k equals to 1, and then I break from the loop. And so if this k equals to 1, that means the item has been already found. That means I just use a printf statement, element say found at position %d, and I am printing I plus 1, right, because the I will be started from 0. Else, that means if the value of k is 0, that means the element is not found. So you can say by using printf, element is not found. That's all. That means that is a simple program of linear search that you can implement with the help of, you can say, array. So That means we are simply do the same thing. That means I am taking an array, the user will give some inputs, it may be any random order, and I want to search for an element, say item will, you can say this item, say I want to search for an element which is 50, which is not present in the array. But what is the procedure? First 50 will be searched with 10, it is not found. Then it will be searched with 20, not found. Then it will be searched with 2, then it will be searched with minus 10, then it will be searched with 5. And since the element is not found, that means k is 0, that means it will print the item is not found in the element. So if we want to talk the how much time your program will take, how you can say much time in the worst case, and when that should be the worst case. Worst case means the element is not present in the array. If the element is not present in the array, that is nothing but the worst case, and for that worst case your for loop will run n times. That means after searching for n times you decide that the element is not present in the array. So that means your program will run n times, and that can be written as order of n, right. So that is nothing but the, you can say specifically, that time complexity, that is specifically called the time complexity of, you can say, linear search, that is order of n, and that is called linear. That means time complexity is linear for linear search, right. So that is the important thing. That means by using array you can do linear search. So by using array you can do two predominant operation. One is called searching by using array, and sorting. In searching you have some like a linear search, you can do binary search, you can do interpolation search, and by sorting, that means there are different type of bubble sort, selection sort, insertion sort, you can say quick sort, you can say merge sort. So there are lots of sort that you can do by using an array. Actually linear search, the complexity is order of n. Worst case, this is a log to n, this is a interpolation log of log n, and in bubbles and in worst case order of n square, in worst case order of n square, order of n square, it is worst case also order of 1 square, and in worst case n log n. These are the complexity, we will see it later if the time permits, but the thing is that by using an array we can do that lots of things. We can do that lots of things. We can do search, we can do sort, we can do matrix multiplications, we can do matrix additions and all those stuffs. So that means array is one of the important property of your important data structure in your syllabus, and that is